This is the second part of a video lecture for Math 140 for Thursday, April 23rd. And the topic again today is the law of cosines. In this part, we're going to apply the law of cosines to two specific example problems. The first has to do with an SAS triangle. SAS triangle is one in which you know a side, another side, and the angle between those two sides. And as we talked about, we can't use the law of sines to solve this problem, but we can use the law of cosines. Let's write down the law of cosines. We have a squared equals b squared plus c squared minus 2bc cosine of angle A. I'm going to label this triangle now. Let's call this angle A. This is angle B, and that's angle C. And this means that this is side length A, this is side B, and this is side C. And what we're going to do is apply the law of cosines to side A here. So A will equal a squared equals b squared, which is 25 squared, plus c squared, which is 30 squared, minus 2 times 25 times 30 times the cosine of angle A, which is 20 degrees. Okay, and if you guys go through the arithmetic on this, a squared comes out to 115. I'll let you guys check the math of that. And then finally, don't forget to take the square root, so a will equal the square root of 115. And this comes out to 10.7. So in this case, a is 10.7. Okay, now we've solved for all the sides of this triangle. We still have two unknown angles. And to solve for one of those angles, we can then use the law of sines. And we're going to solve for angle B. So I can use the law of sines, sine of angle B over side length B, which is 25, equals, and now we have an angle side pair here, right? So I can use angle A, sine of angle A, which is 20 degrees, divided by side length A, which is 10.7. Okay, and then I can solve this for sine of B. So sine of angle B, if we do some cross multiplication, will equal 25 times sine of 20 degrees over 10.7. Okay, that's sine of B, but we actually want angle B, not sine of B. So angle B will equal the inverse sine of all of this, 25 sine of 20 degrees, divided by 10.7, the inverse sine of that. And if you guys plug that in your calculators, you get 53.0 degrees. So this is angle B, this is side A. And now we just have one unknown here, and that's angle C. And that's easy. We can find angle C by subtracting the two other angles from 180. So 180 minus 20 minus 53.0 degrees. And this gives us 107.0 degrees. This is angle C. So now we've successfully solved this SAS triangle using the law of cosines. Okay, I want to do another example with an SSS triangle. Okay, it's example 2. Push this up a bit. Okay, let's suppose we have an SSS triangle, and this is what we have right here. This side is 15, this side has a length of 8, and this side has a length of 10. Okay, this is an SAS triangle because we know all the side lengths, but we don't know any angles. I'm going to label the angles here. This is angle A, C, and B. Let's see if we can solve this triangle. We definitely can't use the law of sines. Can we use the law of cosines? Well, let's see. A squared equals b squared plus c squared minus 2bc cosine of angle A. So let's plug in some numbers here. This is, by the way, this is side A, this is side C, and that's side B, based on the angles. So we have 8 squared equals 10 squared plus 15 squared, okay, minus 2 times 10 times 15 times cosine of angle A. Okay, so in this equation now, we have one unknown, but the unknown is an angle, not a side. But we can still solve it for that angle. So let's square these out. We get 64, this is 100, plus 15 is 225. 15 squared is 225. This looks like we get 2 times 10 is 20 times 15. It looks like this is going to be 150, 300 cosine of angle A. And then we want to isolate this term here. So I get minus 300 cosine of angle A equals 64 minus 100 minus 225. Okay, if you plug that in your calculators, you guys should get, let's see, what does that come out to? Well, we can do this here. This is going to be 64 minus 100 is minus 36. And looks like I did it slightly different in my notes, but that's okay. It doesn't matter which version of this law of cosines you use, so I don't have to do the math in my head here. 64, that's going to be minus 36. Here, minus 225 is minus 231 minus 261. Minus 261, and this means cosine of angle A is equal to minus 261 divided by minus 300. Okay, which equals 261 over 300. And let me plug that in my calculator now. That comes out to 261 divided by 300 equals 0.87. So now angle A will equal the cosine inverse of 0.87. Let's try that. That's equal to 29.5 degrees. Okay. 29.5 degrees, which is angle A. All right. So this is 29.5 degrees. Okay, now we need to find angles B and C. And we can now use the law of sines to do this. And let's find angle B. We use the law of sines. So sine of angle B over side length B is 10. This equals, now we have an angle side pair here. This equals sine of angle A, sine of 29.5 degrees, divided by side length A, which is 8. This means the sine of angle B equals 10 times sine of 29.5 degrees over 8. Let's plug that in our calculator and see what we get. 29.5 sine is that, times 10 is that, divided by 8 is that. This comes out to 0.616. And so that means angle B equals the inverse sine of 0.616. Okay. Let's take the inverse sine. This comes out to 37.8 degrees. This is angle B now, is 37.8. Okay. And this makes sense because it looks like the smallest angle here is opposite to the smallest side. And finally, we can get angle C. Angle C is easy because angle C is just 180 minus the other two angles, minus 29.5, minus 37.8. And if you guys plug that in your calculator, you should get 112 degrees, 112.4 degrees. If I did that right, 37.8, this is, should be a little bit different. This is different than my notes because I did it slightly differently. Let's just do this here, 180 minus 29.5 minus 37.8 gives me 112.7 degrees. Just probably the difference being due to rounding from my notes. So this is our third angle. This is angle C. Okay, we found all our angles, we already knew all our sides, so we've solved this triangle. So this is a second example of an application of the law of cosines. Now I want to mention one other type of triangle to you guys. You might have wondered, isn't there another type, a sixth type of triangle? And there is. You could have an AAA triangle. That's a triangle where, let me make up a triangle here. Let's say we had a triangle like this. Let's say we knew all the angles. Let's say this was 28 degrees. Let's say this was say this was 85 degrees, and then you could find this angle here. That's going to be 95 minus 28 is going to be 75, 65, I think 67 degrees. This would be 67 degrees. Okay, so what if you had an angle where you knew, a triangle where you knew all the angles and none of the sides? Well, these angles uniquely define the shape of the triangle, but since we don't know a side, we know nothing about scale. We know nothing about scale here. So this could be a tiny, tiny triangle or a super huge triangle. And since we don't know any side lengths, we don't know what size it is. So if you're ever given an AAA triangle, there's nothing you can do with it. You can draw it, you can say that's really nice, but I don't know how big or small it is. So you can't go any further. So just kind of a note on that type of triangle. I will see you guys on Thursday.